Hey Royals, in this lesson we're going to look at multiplying and dividing powers that have the same base. And before we get into our formal lesson, I want you to do a couple investigations with me. And the first one is what happens when I'm trying to multiply two powers. Now you'll remember that a power has a base. So here I could have, say, x as my base, and then I have an exponent. So here I might have 4 as my exponent. And together, the base and exponent form what we call a power. And you'll see that formal definition here on our second page once we get to that point. Okay, so we'll remember that a power just simply means repeated multiplication. So if I see this x to the exponent 4, that means I'm multiplying x, our base, 4 times. So I'm going to highlight here and I'll say that this is going to be my first multiplication. So that says that it's x multiplied by x multiplied by x multiplied by x. And that is what I had in yellow. So there's my first power expanded out as repeated multiplication. And we call it expanded form. Now the second one you see there is x squared. So that means that my base is x, and it being squared means I write out the base 2 times. So x times x. Now imagine I had this expanded form written out for us, and we didn't know that it was yellow and red. It was just written as just simply this multiplication, and it was just a series of x's all multiplied together. And you would look at that and go, I don't know what the first power was, but I can see that there is 6 x's there. And so you could say, hey, let's just write it as a single power that has the base x, and it's raised to the exponent, well, 1, 2, 3, 4, 5, 6. So there's 6 of these x's, so I would say it's raised to the exponent 6. Okay, so what we want to do is we want to try this again. So let's jump down to a lower example. So one that's, down here with the h's and the k's. And let's look at what happens if I'm trying to multiply powers that have different bases. So here, let's write out that first power. And that's the first bracket there. I have h to the exponent 3. So that means I have h times h. So the exponent 3 means that my base is going to repeat itself 3 times. And then I have k 4 times. So that's multiplied by k, multiplied by k, multiplied by k, multiplied by k. And this is my first power, or first bracket written out. Okay, so let's look at what happens with the second one. So I'll highlight the second one purple here. That means I have 6 h's. So let's write out 6 h's. 1, 2, 3, 4, 5, 6. I almost wrote a k there, so let's make that actually look like an h. There we go, h. And that the second part of it has k squared. So let's write out 2 k's. K times k. Now, if I was going to just write these as a single power, I'm only going to worry about powers that have, or bases that are the same. And so what I mean by that is I'm going to look at only the h's and count how many h's do I actually have. And I see here I have 1, 2, here let's circle up 1, 2, 3, 4, 5, 6, 7, 8, 9 h's. So I could write h to the exponent, well, 9, because I have 9 of them repeated with each other. And if I did the same with my k's, I could see I have 1, 2, 3, 4, 5, 6. I have 6 k's. So I have k to the exponent 6. So it's really important here is that we only collect bases that are the same, because h is not the same as k, therefore they can't go together under a single power. Okay, so I want you to fill out the rest of this table here and see if you can complete this statement on our page. It says, when multiplying powers with the same base, what do we do? So the ... you're going to tell me what we do as a shortcut when we're multiplying powers that have the same base. So I ask you, pause the video right here and try to fill in the rest of this table and finish that sentence on our screen. So here we go. I filled in the rest of that table and completed the sentence. So we see that when we're multiplying powers that have the same base, we can just simply add the exponents, and we're going to keep that base. For example, if I looked at the one that had the t's, that's this example right here, we can see that it's t to the exponent 6 and t to the exponent 1. So I keep the t as my base, and 6 plus 1 just simply gives me 7. Okay, so now let's investigate what do we do if we're dividing powers. So I'm just going to slide down here on our page, and we're going to have a new table. And one thing we have to remember is that when we divide, if we have the same base in the numerator and denominator, they just simply divide to 1. For example, if I had 5 divided by 5, you would just tell me that that's just 1. If I had 10 divided by 10, you would say that's just 1. What if I had x divided by x? Well, the same rule applies, that if it's the same base, these two will divide to 1. Okay, so let's write out what x to the exponent 7 is. That's in our first example here. So we have x to the exponent 7. So that means I have 7 x's. There's 3, 4, 5, 6, 7. And we're going to draw our giant division line. And we'll have 4 x's in the denominator. So you have x multiplied by x multiplied by x multiplied by x. Now, if we line these up, we can see that this x and this one will divide to 1. And then this x and this x will divide to 1. And I can continue doing this, and you can see that x divides to 1. X and x divide to 1. Well, there's no more x's in the denominator. It's just a series of 1s. And in the numerator, what are we left with? Well, I have 3 x's left over. Well, last time I checked, that means that I can write this as just x to the exponent 3 to represent I had 3 x's multiplied together. Now let's try another one. Let's say a times a times a times a, because there's a to the exponent 4 in the numerator. And let's write out in the denominator, we have a to the exponent 3. And so there's my 3 a's that show up in the denominator, and we apply the same rule. A divided by a is just simply 1. And a divided by a is just simply 1. And a divided by a is simply 1. Well, what am I left with? I'm left with a single a. So I could write that as a to the exponent 1. Or if we didn't want to write the exponent of 1, you could just write that as just simply a. And so one thing that comes out of this is just the knowledge that if there is no exponent explicitly written there, so it doesn't look like there's an exponent, we can always sneak in that exponent of 1. Okay, so I'm going to back off. I'm not going to write the a's there. We'll just have it written like this so that we have a to the exponent 1, which is just equal to a. And again, I'm going to ask you to finish the rest of this table and try to answer that sentence at the bottom. It says, when dividing powers with the same base, ... What do we do? Okay, so pause the video here and see if you can fill in the rest of that table and complete that sentence. So here we go. I've filled in the rest of the table and completed that sentence at the very bottom. So hopefully what you were seeing when you did the rest of the table was that the base will always stay the same, but it's as if the exponents were subtracted from each other. So for example, let's take a look at this example right here, where I have b to the exponent 8 divided by b to the exponent 3. So I started by drawing 8 b's all multiplied together here. And I had 3 b's all multiplied together in the denominator. And each pair of b's divided to 1. And once I ran out of b's in the denominator, I noticed that I had 1, 2, 3, 4, 5 b's left over. And so that led me to say, well, it was just b to the exponent 5, right? And remember, when we're dividing powers, we can only divide terms that are the same. So x divides with x and y divides by y, never x and y dividing each other. Okay, so we can keep the base the same, but just simply subtract the exponents. All right, so let's go a little bit deeper with this. Now, I want you to remember that there's three forms of a power. And the power, remember, has a base. That's this piece here. That's the big number when we write our power. And then it has an exponent. And here it's the 2 is my exponent. And together, if you have a number that's a base and the exponent, and you put those pieces together, you get what we call a power. And I can write this in several different ways. I can write it as exponential form, where you can just simply see straight up what the exponent is. So here it's 3 as the base and the exponent is 6. Or I have x with the exponent of 4. And remember, the exponent tells us how many times we write it out or expand it out. So here with 3 to the exponent 6, we're going to write 1, 2, 3, 4, 5, 6 3s. If it was x to the exponent 4, we can write 1, 2, 3, 4. And that's called expanded form. Now the last form is called standard form. And that's what happens when I put it into my calculator. Now if I put in my calculator 3 times 3 times 3 times 3 times 3 times 3, it tells me 729. Or if I go to my calculator and I put it into 3 to the exponent 6, it comes out and it tells me 729. Right? And I don't actually have to write out the 3 times 3 times 3 times 3 6 times. But the problem is I can't do this on a calculator if I don't know what the value of x is. So we're going to come up with some rules on how do I apply these powers when I'm multiplying or dividing. Okay, so we've already seen the multiplication one. So if I was going to write out 5 to the exponent 3 multiplied by 5 to the exponent 4, we saw that there was a shortcut to this when we're multiplying powers. We said, keep the base the same and add the exponents. Okay, so if I keep the base the same, I see the base here is 5 in both of my powers. So if I follow that rule, keep the base the same, but add the exponents. Okay, so my exponent on the first one was 3. My exponent on the second one was 4. So I can just write 3 plus 4, or just simply say 5 to the exponent 7. Now, if I put 5 to the exponent 7 into my calculator, I find out that I get an expanded form of 78,125. Now, if you're not familiar with how to put this into your calculator, please reach out to your neighbor and see if your neighbor can help you with your calculator. Otherwise, in our next lesson, please let me know and I can help you out with your calculator. Okay, so can we apply these same rules for bases that are just not numbers, right? We can. So we can say that keep the base the same. Here I notice that my base is x. So I'm going to keep the base as x. And I can add my exponent. So 2 plus 7. So if I go x to the exponent 2 plus 7, that's just simply 9. And you can see here on the right hand side, that is exactly what we summarized this rule as. So this is called the product of powers. Product is another way of saying multiply. And I'm going to use the word multiply as well. Multiply. Right? We're multiplying powers. Okay, so let's try this with dividing powers. Now, division, we need to remember, is written this way, or I can write it as 4 to the exponent 7 divided by 4 to the exponent 3. And in our investigation, we came up with a rule. We said, hey, keep the bases the same and subtract the exponents. So let's try that with this example. So it said, keep the bases the same. My base is 4. In both cases, here I have that 4 as my base. All right, so I keep the base 4 and I subtract my exponents. Well, I'm always going to subtract the first one. Sorry, I'm always going to subtract 7, subtract 3. So the second one away from the first one. So that's 7 minus 3. All right, so 7 minus 3, that's 4. So I have 4 to the exponent 4. And when I put that into a calculator, I get 256. Again, if you need help with your calculator, reach out to your neighbor or ask me in the next time we see each other. Okay, so let's apply the same rules for powers that have a base that is, a variable, a letter. So we keep the base the same, y, and we subtract our exponents. 12 subtract 9. Now 12 subtract 9 is 3, so I can write that as y to the exponent 3. And this sure as heck is a lot faster than writing out our power as simply like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then the denominator, there's 9 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then going 1 from the top, 1 from the bottom. 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 And I'm just going to go until I run out. 1 from the top, 1 from the bottom. And then 1 from the top, 1 from the bottom. And sure enough, here we go. We got 3 of them left over, which was y to the exponent 3. Right? So here's the short form. If we have division, we're dividing powers with the same base. Now it has to be the same base. We keep the base the same and we subtract the exponents. Okay, and this is called quotient. That's another way of saying division or divide. Okay, there we go there. So that sums up what we're going to do here. So on the next page, it says your turn. So this is your turn to try to simplify these as a single power first. So that, remember, we want to just make sure that we have one base, one exponent. So we're getting something like x to the exponent, I don't know, a, right? And then evaluate if you can. Okay, so challenge yourself to try to do these 2 problems here. And then if you want to go even further, there is a challenge question at the bottom of our page. Now, I will post these solutions at the end of this video. So please pause this video, try the rest of this page yourself, and then unpause the video to check your answers. So here is the solutions to the first question. And here's the solution to the second question. Now, if you were up for the challenge on this lesson, here's the solution to that challenge question. And as always, if you have questions about anything in this lesson, please don't hesitate to reach out to me.